Channel. So today we shall be looking at another technical coding question. Uh, find the largest value in each tree row. So the question says that given the root of a binary tree, return an array of the largest value in each row of the tree, zero index. So let's see an example. So you have this tree and we're returning 139. So in each row, so tell me what to look level by level. So 1 is the first, 3, then here 9. Wow. So here 1, 2, 3. So 1, 3, here 1, here 1, 2. The number of nodes in the tree will be in the range 0 to 10 raised to the power 4. Okay, and the value could be negative up to positive. Wow. So how do we approach this problem? Find the largest value in each tree row. Immediately we can see that there are some, if we have these cases, if we have an empty, we just return empty, and if we have just the root, we just return that value of the root. So we can quickly take care of those cases. But as we have more, we want to look at, can we have a way of keeping track of each levels? So if you have a way of keeping track of each levels, then we can choose the largest in that level and add it to the array that needs to be returned. So that would be a BFS, a breadth first search. So we keep track of each levels, and in each of the level we choose the largest value. That's the approach I think we can go about it. So let's see. So first, if not root, so if there's no root, we know we just return the empty lists, and if not root dot left and not root dot right, so we can just return the value in the root. So and we put the root dot val here. Okay, so that handles those base cases. Now this point is when we have either left tree or right tree or both of them. So we want to do like a BFS. Now we want our result largest value in each arrow. So we call the largest value in each row. So it's an array, and we make that's a list that we will eventually return at the end of our program. Okay, so now we want to do a kind of BFS. So that means we need an helper function that will help us keep track of the level, and we can now pick the maximum from each of the level. So to do a BFS, we can go down and we'll keep track of this, So we keep track of the levels. From this is level 0. So if we see anything, we add it to that level. So the best way I would think about it is that why don't you keep a list that contains all the levels? Then we now take the maximum. So what I mean is we just have a list that has a multi-list, so that keeps the first level this way, it keeps the second level, then it keeps the third level, which is 539, and at the end we will just now iterate through this list and we'll just pick the maximum of each of these, and that will go into our largest array. So let's do it that way. So now we need to define a BFS as an helper function. So the BFS, and that's going to take a root or a node. And let me just, for clarity, let's use a node. And we expect our BFS to also it should also take an empty list. Let's say I've not figured that out yet. Okay, so essentially what our BFS is, we're going to have BFS recursive call on node that left, and we also have BFS recursive call on node dot right. All right, but now we need to keep track of the levels. So we need something like a level, and we also need an empty list where we will add those values. All right, so the first level is going to be 0. So what I will just do here, because at the end we're going to call BFS. So BFS, we're going to send in the root, we're going to send in the level as 0, we're going to send in the result as an empty list. So we need that. So this will be like a temporary list. So okay, all right. So by the time we call the node dot left, we also increment the level by 1, and we carry the temp along. So by the time we call this, we also increment the level by 1, and we call this. So what we want to do here is to be able to put the values in the temp. So we'll do if level, if the level is, so we need a way of comparing each level, so we go by levels by level. So how do we compare that level? Because we need to keep adding. I think we also need our largest value as well here. We need our largest value as well. We need this as well here. So that we check the length of the largest value, because we want to keep creating this guy. So we check the length of the largest value if it is the same thing as the length of our levels. So if the length of that array, of this array, okay, so which will be 0 now, if it is equals to the level, okay, so what we want to do is we want to append that value. So we want to use that largest value and append an empty list. Alright, so we append an empty list into that. Then we will now use that largest value and the level to append the current node value. Oh, very trickish. Okay, so that's what we want to do. So such that at every level, as we are going through, we are populating this list, but we have to keep creating this list on the fly, this array on the fly, because initially our largest value is this, array is this, but we want to populate it with other array inside. So we need to create that on the fly on the basis of the level that we're in. So if we get into a new level that does not exist before, what we want to do is we want to create this empty, then we want to pick that level and put in our value. But if it already exists, so if the length, if it's already equals to the level, then we know that we already have that existing, then we can just add that into it. So this one will be and largest value. So I don't think we need a temp anymore, so we don't need a temp anymore. So this is what we need here. So we don't need this temp anymore. Okay, and we don't need this anymore. Very trickish. So let's do a run through and see how well this works for us, because at the end of the day we will need to now go through the largest value and just return the max in each of them, or to make things better, what we can do is, instead of us again iterating through a list like this and getting the max value, what we can do is we can do another check here before we append the node.val into it. We want to check the value there. If the value is less, then we replace it with this. Okay, so we can say level 0, because we just expect one element to be there. Okay, will be equals to the max of the new ones, the one that is there before our time is up, so we're already done with the time, and the node.val that we're just adding. That's the one that we're just adding now. So we want to get rid of this. So essentially, we will not need to keep all of them. So once we already put the first one there, okay, so we also have to do some check here to make sure that we have the first one. So we want to check if this one, so that we'll not run into index error. So we want to check that if this one is empty, or if it has a value. So we want to check if there is a value there already, then we want to do this check. If there's no value there, then we just append. Else we just append the node value into it originally, like we wanted to do. So we just append that. So what we're doing is we're checking if this exists, if there's something in the level, then we want to pick that something and replace it with the maximum of itself and the new value, so that we keep only the maximum in the level. Else we just want to append into that level. Okay, so that at the end of the day, this we just keep what we need. But there is another challenge here, because we are returning a list and we are appending this. So do we need to append this one in that case? So that's something interesting we need to check that, because we don't need this one anymore. Then we don't need to append this anymore. So how do we handle this? So we check if the length of the largest value array is equals level I think it's difficult for us to be able to do this right away. So let's just go back to what we're doing before. So we may want to just get rid of this and just pick that largest value and the level, then we append the node val. Then at the end of the day, what we're going to do is we will have to run through for val in the largest value array. We may just want to store a result dot append the max value, just the max value there. Then here we just return the result. Then we want to make sure we keep the result as an empty list. Okay, that should work. So let's do a run through now and see where we have missed anything. So 1, 2, 3. It's a bit trickish. So this passes, this passes. So we have this initialized, we have our BFS defined, so we can get rid of this, clean our code. Okay, so we call our BFS on the root, which is 1, the level is 0, the largest value array is empty. So we come in here, so this one is, the node is 1, the level is 0, the largest value array is empty. So we check if the length of the largest value, so the length is 0, and is it equals the level is 0. So I think we need to change this because we don't, yeah, if it's equal, well, okay, so we should append this if it is equal. All right, so we will append into our largest value array, so this is going to become this at this time, so append an empty, then we take the level, which is 0, so referring to this, and we append the node val, which is 1, into this. Then we do a recursive call. This time around, our level, our left is 2, the new node, our level becomes 1, and our array is this with 1. So with this recursive call, so when we come in here, the node is 2, the level is 1, and our array is this new one. And it comes in here, if the length, what is the length of the largest value is 0, is 0 equals to the level, which is 1? No, it is not. No, it is. The length is 1 because initially the length was 0. So the length is 1 now. So it is. That means we append another one inside. So we append another one here. So we append another one. Then we pick that level, which is 1, and append the value, which is 2, inside. Okay. Then we come in here. Remember our level was still, for this one, because of the recursion, the level here will still be 1. Okay, because when we backtrack, it's difficult to think. When we backtrack, the level is still 1, but our node.write is 3. So the level is still 1, and we have our new list here. So we have 3, 1. So we check if the length, so the length is 2. Is it equals to this? No, so we don't. So we already have the level. We pick the level of 1, then we append that to this constraint. Okay, so this does make sense. So when we now go through each of the value here, we pick the maximum and append it to result, then we return result. Oh, that takes some time. Let's run that. Let's see. We have a problem there. We are having a non-type largest value array level dot append node dot val. So we are having a non-type. So we did not define when to backtrack. So we need a base case. It's a base case that we're missing, that if not node, we need to return. So we're missing that base case. So if the node does not exist, we just return. Let's see again. Yeah, that works. So let's see this other one. And see this one. That works too. And let's see the rest. And let's see this. Okay, all of them. Well, all of them passes. So let's submit. Let's see what we have. Yeah, that works. All right, it took some time. And thank you very much, and see you in the next one.